This video is for class 10 mathematics students. The chapter here is Introduction to Trigonometry, and in this video I am solving exercise 8.1 of NCERT textbook. Okay, so let us see. Introduction. See, this is a mountain. Now, when you see the mountain, the first question which came to the people's mind was, what is the height of these mountains? So people were very curious to know how to measure the height of mountains. Then clouds. How high is the cloud above the ground level? Or you see, an aeroplane. At what speed is the aeroplane flying? To answer these questions, people were always on the thought that how to find a solution to these problems. So man always had these queries and wanted to find a solution to these questions. This led to the birth of trigonometry, which made it possible to find answer to all these questions. So trigonometry is helping you to find things which you cannot physically measure, which you cannot take a tape and measure the height or the cloud. There we make use of this trigonometry. So that is why this subject has been developed so that we can measure the things. So tri means three, gon means sides, and metron means measure. So trigonometry is the study of relation between the sides and the angles of a triangle. Since height is a vertical distance between the object and the surface of the earth, right angle triangle is used. So in this chapter, we will study some ratios of the sides of the right triangle with respect to its acute angles called the trigonometric ratios of the angles. So the whole chapter is based on these ratios. There are 6 ratios, basically 3 fundamental ratios and 3 are the reciprocals of these fundamental ratios. Totally we have 6 ratios and the whole trigonometry rests on these 6 ratios. So if these basic concepts are very clear, you are through trigonometry. So it's not very difficult thing, only a few ratios you have to remember it, and I will tell you how to remember it and what are the values you have to calculate everything. So let us begin. A quick review of the ratios. Which are the ratios? Now, as I told you, it's a right angle triangle. So it's a right angle triangle. This is the right 90 degrees angle. And here is the angle which we name it as theta. So if this is the angle, the side which is in front of it, we say it is the opposite side. And the side which is below side is the adjacent side. And for a right triangle, the longest side you know is always the hypotenuse. So we name the 3 sides of the right triangle as opposite, adjacent, and hypotenuse. And this is with respect to angle theta. If you change the angle to this angle, then opposite will be here, adjacent will be here, and hypotenuse will not change its position. So it's a relative term. Adjacent and opposite, they depend upon which angle you are talking about. If you are talking about angle C, opposite and adjacent is here. If you talk about angle A, opposite is here, adjacent is here. So that's why just keep a note of that. What is opposite means what and adjacent means what. Okay. So now first is the basic fundamental ratios. First ratio is called as a sine of the angle theta. It is sine of angle theta. It is not sine into theta, mind you. Okay. So SIN is sine. Sine is in short written as SIN, sin theta. Okay. The definition is opposite side upon hypotenuse. Opposite is what? AB is opposite. Hypotenuse is AC. So we write sine of angle theta is AB upon AC. I repeat again. Sine theta means it is a sine of angle theta. It is not sine into theta. Clear? So It is just don't confuse it with that, because when you write something same, there's no sign between them. It's a multiplication sign. So it's not a multiplication. It is the sine of the angle theta. That is the meaning of this. Okay. Next, we go to cosine. Cosine is called as cos theta. In short, cosine is in short written as cos theta, and it is defined as adjacent side upon hypotenuse side. Adjacent with the angle respect to angle theta is BC, and the hypotenuse is AC. So it is BC upon AC. Third ratio is tangent theta. Tangent theta, that is in short, is written as tan theta. It is opposite upon adjacent. Opposite with respect to this angle is AB, and adjacent side with respect to this angle is BC. So AB upon BC. So these are the three basic fundamental ratios. So based on these three ratios, the rest of the thing also. So we take the reciprocal of this. I take 1 upon sine. So the reciprocal of this or basic or fundamental ratio is, first reciprocal of sine is cosecant theta, or it is known as cosec theta. It is hypotenuse upon opposite. Hypotenuse upon opposite. This is opposite upon hypotenuse. The reciprocal is opposite, hypotenuse upon opposite. That is AC upon AB. You compare it with this. AB upon AC, it is AC upon AB. So it is just the reciprocal, okay? So you can say cosecant is the reciprocal of sine. Reciprocal of cosine is secant theta. It is read as sec theta, SEC, sec. Sec theta, it is hypotenuse upon adjacent. See here, cos is adjacent upon hypotenuse. This is the reciprocal, hypotenuse upon adjacent. So it is BC upon AC, it will become AC upon BC. Now, reciprocal of tangent is cotangent. Cotangent theta, it is known as cot theta in short. So these are the terminologies. We don't write this full word every time. We just use cot theta. So this is cot theta is adjacent upon opposite, that is BC upon AB. Adjacent is BC, AB is opposite. Compare it with this, AB upon BC, BC upon AB. So these are the reciprocal ratios, and these are the fundamental basic ratios. Totally, these 3 plus 3, we have got 6 ratios in all. Now, we need to remember these 3. So how do you remember? Tip to remember the above 6 ratios. Say this. OAO upon HHE. So from top to bottom, if you come, this is sine. Opposite upon hypotenuse. Top to bottom, you come from the middle, adjacent upon hypotenuse is cos. Top to bottom, the last one, opposite upon adjacent is tan. So when you come top to bottom, it is sine, cos, tan, the basic ratios. And from bottom to top, if you go, this is H upon O is cosec, H upon A is sec, and cot is A upon O. Okay. So this is how you remember. OAO upon HHE. So you elaborate this and write it as Om Anjaneya Om Hara Hara Anjaneya. Om Anjaneya Om Har Har Anjaneya. Remember this, all the 6 ratios you have learned it. Clear? This is how you go to remember the 6 ratios. So based on the 6 ratios, we do the full remaining calculations. Now we start with exercise 8.1. The first exercise of this chapter, and the question 1. See, what is the question? In triangle ABC, right angled at B. AB is 24 centimeter, BC is 7 centimeter. Determine sin A, cos A, sin C, cos C. So it's only a practice sum so that you understand how to write the values. So let's draw the figure. Now see, this is the figure. Right angled at B. So this is 90 degrees here. And ABC is a triangle. He has written AB is 24, AB is 24, and BC is 7. Okay, so this figure is not correct to the measurement, but an approximately, because we are not going to draw 24 centimeter. So neither it's in a ratio also, it's approximate figure. Okay, now that's solution. How to solve it? Now see, since the required ratio, that is the sine and cos, since the required ratios have length of hypotenuse in the denominator, we need to find the length of the hypotenuse. So that means in these ratios, we have got opposite upon hypotenuse. That means hypotenuse length I must know. And here hypotenuse length is not given. So what I do, we use Pythagoras theorem to find the length of the hypotenuse. What is the Pythagoras theorem? AC square, hypotenuse square is equal to AB square plus BC square. AB square plus BC square. So AC square is equal to 24 square. AB is 24. So it is square of that. And BC is 7. So 7 square. So we do that. 24 square is 576 and 7 square is 49. Let's add these two. You will get AC square is 625. So AC will be square root of 625, which is 25. That means this particular length is 25 centimeters. Now, let us start writing the values. Sine of the angle A. What is sine? Sine is opposite upon hypotenuse. Angle A is here. So the opposite is here. So it is BC upon hypotenuse AC. So BC is 7, AC is 25. So sine of angle A is 7 upon 25. Cos of angle A, adjacent upon hypotenuse. Adjacent is angle A is here, so adjacent is this side, and AC is this. So AB upon AC, that is 24 upon 25. Next, sine of C. Sine of angle C. Angle C is here, opposite is this, and hypotenuse is 25. So AB upon AC, that is 24 upon 25. Okay, and cos of C is adjacent upon hypotenuse, that is adjacent angle C with respect to this angle BC is the adjacent and AC is the hypotenuse. So 7 upon 25. Clear? So you just for a few more sums, you keep writing this. So you write this thing, write this. So if you write this, it will in a few sums to solving, when you solve a few sums, you'll be able to remember them. And after that, you don't have to write again automatically. The moment you see the ratios, you can write the values. Question number 2. In the given figure, find tan P minus cot R. So what is the figure? This is a figure. Tan P, and so P is here and R is here. So here again, we need to find this side. So to find tan and cot, we need the length of QR. We need this length because opposite adjacent, because we don't need the hypotenuse there. So we use Pythagoras theorem to find the length of QR. PR square is equal to PQ square plus QR square, which is equal to 13 square is equal to 12 square plus QR square, which is 169 is equal to 144 plus QR square. QR square is equal to 144 minus, so 169 minus 144, which is 25. So QR will be square root of 25, which is 5. That means this length is 5 here. Yeah. Next. Now what we need tan of P. What is tan? P is here. Tan is opposite upon hypotenuse. Opposite upon adjacent. So QR upon PQ, that is 5 upon 12. Cot, adjacent upon hypotenuse. Cot of R This is R, adjacent is 5 and opposite is 12. So 5 upon 12. Now, tan P minus cot R. So put the values. Cot P minus tan P minus cot R is equal to 5 upon 12 minus 5 upon 12, which is 0. So tan P minus cot R is equal to 0. Question number 3. If sin A is equal to 3 upon 4, calculate cos A and tan A. This is the figure. So in this figure, sin A, what is sin? Opposite upon hypotenuse. The opposite is 3, hypotenuse is 4. So if you see here, sin A is equal to 3 upon 4, which is given. So what is sine? Sine is opposite upon hypotenuse. That is 3 upon 4, which is equal to BC upon AC. That means BC is 3, AC is 4. So BC is 3, AC is 4. Now you need to find this length. We use Pythagoras theorem to find the length of AB. So AC square is equal to AB square plus BC square. 4 square is equal to AB square plus BC square. That is 16 is equal to AB square plus 9. AB square is equal to 16 minus 9, which is equal to 7. Therefore, AB will be square root of 7. So this length is square root of 7. Now you know all the three sides. Let's write the ratio. Cos. What is cos? Adjacent upon hypotenuse. What is adjacent? Which angle we are talking about? A. Adjacent is root 7. Hypotenuse is 4. So root 7 upon 4. Tan. Tan is opposite upon adjacent with respect to angle A only. So opposite is BC and adjacent is AB. So 3 upon root 7. So these were the two values which we were asked. So we have calculated the two values. Now question 4. Given 15 cot A is equal to 8, find sin A and sec A. So 15 cot A. 15 cot A solution. 15 cot A is equal to 8, which is given. So cot A is equal to 8 upon 15. So that is, what is cot? Cot is adjacent upon opposite. So that means adjacent is 8, opposite is 15 with respect to angle A. So angle A is here, adjacent is 8, opposite is 15 with respect to angle A. Now, we use Pythagoras theorem to find the length of AC. What is Pythagoras theorem? AC square is equal to AB square plus BC square. So AC square is equal to 15 square plus 8 square. 15 square is 225, 8 square is 64, that is 8 8s are, and 15 15s are 225. Add these two, you will get 289. AC square is 289. So AC will be square root of 289, which is 17. So this length here is 17. Now, we need to write the value of sin A. What is sin? Sin is opposite upon hypotenuse. Sin A is opposite upon hypotenuse. Opposite is 15. Hypotenuse is 17. So it is 15 upon 17. Sec A. Hypotenuse upon adjacent. Hypotenuse is AC, which is 17, and adjacent is AB, which is 8. So it is 17 upon 8. Question 5. Sec theta is equal to 13 upon 12. Calculate all other trigonometric ratios. So one ratio is given. So we need to calculate all the remaining. Totally we have 6 ratios. One ratio is given. So we are left with more 5 ratios. We have to calculate all the 5 ratios. Now solution. So first Sec theta is equal to 13 upon 12, which is given. Now, this is the figure. What is sec? Hypotenuse upon adjacent. Hypotenuse is 13, adjacent is 12. Hypotenuse is what? As per this figure, hypotenuse is AC and adjacent is AB. So 13 upon 12. Now, we use Pythagoras theorem to find the length of BC. So if you see here what we have done, almost every question we have the same pattern. Only know the ratio, two sides will be given, calculate the third side and write the remaining ratio, whichever ratio you are in need of. Okay. So now let's see what is Pythagoras. Now I can use this way. Instead of writing AB square, BC square, AC square like that, I can write H is hypotenuse equal to O square plus A square. H square is equal to O square plus A square. O is opposite, A is adjacent, H is. So if you see here, H is 13. A is, they are the first letters of all these things. So H is 13. So here 13, A is 12. Here 12, you have to calculate O. It is simply. So if you remember this, if you don't remember the Pythagoras theorem or anything, just you can write it in this form, write this way and start writing in this way. So 13 square is 169. O square is equal to 12 square is 144. Take this one this side. O square is equal to 169 minus 144 is 25. So O is equal to the square root of 25, that is 5. So this length is 5. Again, I tell you, the measurement, the figure is not according to the measurement, it's an approximate figure. Get an idea how it will be look and how it will, which side will be of which length. Okay. Now, let's write all the other ratios. First ratio, sine. Sine is O upon H. O is 5 and H is 13. So 5 upon 13. Without the figure also you can write it. You don't have, you need not draw the figure, just you remember this, you can write cos A upon H. A is what? What is A here? 12. And what is H? 13. So 12 upon 13. Tan. Tan is O upon A. What is O? 5. What is A? 12. So it is 5 upon 12. Again, now reciprocal of this. Cosec. Cosec is H upon O, which is 13 upon 5. This reciprocal of cos is sec, which is already given. So I'm not going to write this. Then I go to this. Cot. Cot is the reciprocal of tan. So that is 5 by 12. This becomes 12 upon 5. So this is the 5 other ratios. When one ratio is given, you calculate the other 5 ratios. Question 6. If angle A and angle B are acute angles such that cos A is equal to cos B, then show that angle A is equal to angle B. Angle A and angle B are acute angles. This is particularly mentioned because you know in a triangle, one angle is 90. That means the other two are acute angles. That's why these two are acute angles. So angle C, so none of them is 90 degrees. Solution. Cos A is equal to A upon H. That is AC upon AB. Cos B is equal to A upon H. That is cos A. See here, once again I start. A is here. So with respect to this angle, the adjacent is AC, hypotenuse is AB. Then when you talk about cos B, that means with respect to this angle, adjacent is BC and hypotenuse is AB. Okay, so that's how you write cos A is equal to AC upon AB and cos B is equal to BC upon AB. But we are given that cos A and cos B both are equal. But cos A is equal to cos B. If cos A is equal to B, that means this ratio and this ratio both must be equal. This is given. So AC upon AB is equal to BC upon AB. The denominators are same. The numerators also must be same. Only then these two ratios will become equal. So since the ratios are equal and the denominators are equal, so their numerators must be equal. So what you can say? So from that you can conclude AC is equal to BC. If AC, this side and this side both are equal, then angle A must be equal to angle B. Why? Because angles opposite equal sides are equal. So they must be equal. Clear? That's all. It's not a very difficult proof. Just simple logic. Seventh question. Cot theta is 7 upon 8. You have to find the value of this. Evaluate means find the value of this expression and find the value of cot square. Now, this is the figure. Theta, sine theta, cot theta is 7 upon 8. So, what is cot? Cot theta is 7 upon 8, which is given. Cot means adjacent upon opposite. Adjacent is 7. This is angle theta. Adjacent is 7. That means AB is 7. And opposite is 8. That is BC is 8. AB is 7. BC is 8. Now, we use again Pythagoras theorem to calculate AC. Okay. There's a mistake here. It should be AC here. O square plus A square is equal to H square is equal to O square plus A square. Okay. So instead of such things, you can, if you use this, there won't be any mistake because A is 7, O is 8. So let's A and O values, we put it. H square is equal to 8 square plus 7 square, 64 plus 49 is equal to 113. So H is equal to square root of 113. 113 is not a perfect square. So you will get the answer and not go in decimals. So don't find it. Simply keep it as it is and make a note here that it is 100 root of 113. Once you do this, now take this expression. Sine is what? Opposite upon hypotenuse. That is 8 upon. Opposite is 8. Hypotenuse is root. So 8 upon root 113. Cos. Adjacent upon hypotenuse. Adjacent is 7 and hypotenuse is root 113. 113. So these are the values of cos and sine and cos. Now let's put them in this expression. This is the expression. Let's put the values. Sine is 8 upon root 113. Cos is 7 upon root 113. Let's put the values here. So this is the value of sine. 1 plus sine 8 upon root 113 plus 1 minus 8 upon root 113. 1 plus 7 upon root 113. 1 minus 7 upon root 115. Now you see here, you don't try to multiply. Now you see here, a plus b, a minus b. A plus b, a minus b is what? A square plus b square. So we are using that concept. So a plus b, a minus. So this is a, this is b, a, b. A plus b, a minus b. So you are using the concept a square. A plus b, a minus b is equal to a square minus b square. So it is just 1 square minus 8 upon root 113 square. A square minus b square upon a square minus b square. So 1 square is 1 and 8 square is 64 and root 113 square is this root and square cancels and it is just 113. Similarly, in the denominator 1 minus 49 upon root 113 means 113. That is equal to, take the LCM here, 113 minus 64 upon 113. 113 minus 49 upon 113. Subtract this two, you'll get 49 upon 113 and 64 upon 113. So this is a division. So it should be 49 upon 113 divided by 64 upon 113, which is equal to 49 upon 113 into 113 upon 64. This and this cancels. So your answer is 49 upon 64. So the value of this expression is 49 upon 64. Now the other is the second part, which is that. So let us take it. Cot square is equal to cot is what? Cot is 7 upon 8. This is given. So what it will be? Square. It will be 7 upon 8 square, which is equal to 49 upon 64. So both are equal. Getting it? So you are getting the same values. But they have not asked you whether it is equal or not. So they just told you independently calculate the two values and they have done it. That's all. But for your inference, I'm just telling you that 1 plus sine theta, 1 minus sine theta upon 1 plus cos theta, 1 minus cos theta is equal to nothing but cot square theta. The values are same, so you can say these two are equal. That's a little additional knowledge about it. That's all. Next. Next question. Eighth question. 3 cot A is equal to 4. You have to check whether this and this expression both have the same answer. 3 cot A is 4. Okay. So cot A this is given. So cot A will be 4 upon 3. That is adjacent upon opposite. So your figure will be like this. And therefore, and what is tan A? Tan is 1 upon cot. So is the reciprocal of cot. Cot is the reciprocal of tan. Therefore, 3 upon 4 it will become. So 1 minus tan square A upon 1 plus tan square A will be 1 minus 3 upon 4 whole square upon 1 plus 3 upon 4 whole square, which is 1 minus 9 upon 16, 1 plus 9 upon 16. Okay, I hope you understand this. 3 square is 9, 4 square is 16. Now take LCM of the numerator and denominator separately. The 16 minus 9 upon 16, 16 plus 9 upon 16, which is 7 upon 16 divided by 25 upon 16. That is 7 upon 16 into 16 upon 25. These two cancels. Therefore, your answer is 7 upon 25. Okay. So this expression, this first part, we got the answer of this as 7 upon 25. Now we got to go for this. Here we have got sine and cos. So you need to find the value of this AC. Let's go for the next. Continued with this solution. We use Pythagoras theorem to find the length of AC now because we need sine and cos. So again we go AC square is equal to AB square plus BC square. That is 4 square plus 3 square. That is 16 plus 9. AC is 25. So AC is equal to square root of 25, which is just equal to 5. This is 5. Now let's see what is sine. Sine is opposite upon hypotenuse. Opposite is 3, hypotenuse is 5. 3 upon 5. And what is cos? Adjacent upon hypotenuse. Opposite adjacent is 4. Hypotenuse is 5. So 4 upon 5. What he asked us to calculate? Cos square minus sine square. So cos square means square of this number and minus square of this number, which is 4 upon 5 whole square minus 3 upon 5 whole square. Take the square. 4 square is 16 upon 25. This square is 9 upon 25. LCM is denominator is same. So just write 16 minus 9 upon 25. Subtract it. You'll get 7 upon 25. So if you see here, therefore, here also we got 7 upon 25. Here also we are getting 7 upon 25. So both these values are equal. Hope it's clear. Now let's take the next ninth question. In triangle ABC, right angled at B, tan A is equal to 1 upon root 3. Find the value of this. Tan A is equal to 1 upon root 3. This is given. So tan A is what? Opposite upon adjacent. That is BC upon AB. So that means first let's draw the figure. It is like this. So BC upon AB is 1 upon root 3. Because now, by using Pythagoras theorem, we calculate AC. H square is equal to O square plus A square. This is O, this is A. O is 1, A is root 3. So let's put it here. 1 square plus root 3 square, that is 1 plus root 3 square is 3. Therefore, H square is 4. So H is equal to square root of 4, that is 2. That means this angle's length is 2. Now, we calculate sorry, this is a figure. Now let's calculate sine. Sine is what? Opposite upon hypotenuse. Opposite is 1, hypotenuse is 2. So it is 1 by 2. Sine cos A. Cos is, with respect to the cos is root 3 upon 2. Adjacent upon hypotenuse. Then let us calculate sine C. C is here. Opposite is root 3 and hypotenuse is 2. So it is root 3 upon 2. Cos C is 1 upon 2. Now, so we have calculated. So be careful with the opposite and adjacent when you are taking angle A and angle C. Okay, opposite here is 1 and here the opposite is root 3 because with respect to this angle, opposite is 3, root 3. And with respect to this angle, opposite is 1. And with respect to this angle, adjacent is root 3. And with respect to this angle, adjacent is 1. Now, sin A cos C plus cos A sin C. Now, sin A, what is sin A? 1 by 2. Cos C is 1 by 2. So let's put the values. 1 by 2 into 1 by 2 plus cos A root 3 by 2 into cos C root 3 by 2. 1 1s are 1, 2 2s are 4. And root 3 into root 3 is 3, 2 2s are 4. So it is 1 by 4 plus 3 by 4. LCM is 4. So 1, 4, 1 plus 4, which is 4 upon 4, which is equal to 1. That means this answer is only 1. Next part. Cos A cos C minus sin A sin C. Again from this let's put the values. Cos A root 3 by 2, cos C 1 by 2. Okay. And sin A is 1 by 2, cos C root 3 by 2. So let's put the values. Root 3 by 2 into 1 by 2 minus 1 by 2. Root 3 into 1 is 1. Root 3 upon 4. And this is also root 3 into 1 is root 3 upon 4. Root 3 upon 4 minus root 3 upon 4 is 0. So this expression value is 0 and this is 1. 10th question. In triangle PQR, right angled at Q, PR plus QR is 25 and PQ is 5. Determine the value of sin P, cos P and tan P. Let us find this value. So an expression is given. Now it is a sum of the two side lengths. PR plus, so let us see how it is. This is PQ is given as right angled at Q. That means this is 90 degrees and this is PQ is 5. This length PR plus QR, PR and QR, these two lengths together is 25 centimeter. You have to find these three ratios. Now let us see. PQ square plus QR square is PR square. PQ square. Okay. I just using the Pythagoras theorem. by Pythagoras theorem. This is the hypotenuse. So PQ square plus QR square is equal to PR square. Now PQ is given 5. Let's put the value here. Pi square is equal to QR square minus PR square. Pi square is 25. 25 plus QR square is equal to PR square. PR square minus QR square is 25. Clear? So PA square minus B square. So you use it as A square minus B square is A plus B, A minus B. That means this plus this minus this. So you can write it as PR plus PQR. PR minus QR is 25. PR plus QR. PR plus QR is given 25. So we put this value 25 is equal to P into PR minus QR is equal to 25. Bring this down. So it will be PR minus QR is 25 upon 25 is 1. Okay, this is your first question. And this is your second part. PR plus QR is 25. This is your second. Let's add these two. That is PR plus QR plus PR minus QR is 25 plus 1. QR cancels. So PR plus PR is by adding this 2 PR is equal to 26. PR is 13. Yeah. So 26 divided by 2 is 13. So PR is 13. PR, this length, PR is 13. So let's write 13 here. Now, what is given? PR plus QR is 25. So let's use that PR plus QR is 25. So we have just found the value of PR as 13. So put it there. 13 plus QR is 25. So QR is equal to 25 minus 13. That's equal to 12. So that means this length is 12. Now we need to calculate this three ratios. Sine. Sine is O upon H. O is 12 and H is 13. So 12 upon 13. Cos P is A upon H. Phi is A and H is 13. 5 upon 13. Tan P. Tan P is O upon A. That is 12 upon 13. 12 upon 5. So these are the three values of sin P, cos P and tan P. Next we go to the next question. Question 1. State whether the following are true or false. Justify your answer. The first one is the value of tan A is always less than 1. In the just previous question we have seen tan of P is 12 upon 5. 12 upon 5 is 2.4, which is greater than 1. So saying that is always less than 1 is a false statement. Therefore, this is false. Okay, the previous question which we got it from that example only I have taken. Okay, so it is I are able to show you the previous one. See here, tan is 12 upon 5. Okay, with respect to this everything is fine. So we are getting a tan 12 upon 5. So I'm using this value to just justify this particular thing. Okay, 12 upon 5, which is greater than 1. So that means what we say is false statement. Clear? Now, sec is equal to 12 upon 5 for some value of A. Here, sec is 12 upon 5 means sec is hypotenuse upon adjacent. Hypotenuse is bigger than the adjacent. Hypotenuse is greater than the adjacent. Therefore, it's a true statement. Third one, cos A is the abbreviation used for cosecant of angle A. Now, cosine A is cos A. Okay, cosine A is cos A, not cosecant. So this is a false statement. Next, cot A is a product of cot and A. In the first question itself, I told you when it is written this, it is the angle cot of the angle A. It is not cot into A. So same way, it is the cot of angle A, not cot into A. Therefore, this is also a wrong statement. It's a false. Next, sine theta is equal to 4 upon 3 for some angle theta. Now, sine is opposite upon hypotenuse, and here the opposite is greater than the hypotenuse. Opposite is greater than the hypotenuse, because in a right angle triangle, hypotenuse is the longest side, and opposite and adjacent cannot be longer than the hypotenuse. So this is also a false statement. So I think this is the end of this exercise. Hope you have understood the whole thing clearly. Now, if you have understood the thing, if you find the thing, please, my channel is Easy Learning. Subscribe for this for more videos on this chapter, and also, so I am actually adding all, solving all the exercises from all for all chapters of class 10th, 9th, and 8th. So if you, those who are in 8th or 9th or 10th, it will be useful. If you have understood, please subscribe and click on the like button and hit the bell icon. Hope everything is clear. Clear?